Hey, good second morning, my neighbors. Nuclear mold. Nuclear mold. Ought to be a movie, right? Like The Blob or something, eh? So, an innocuous question from fellow YouTubers made me think of this short but might turn long video. So, I do fives or 20s usually. We'll see where this one ends up because we're talking about mold now. Mold. Now, the first thing I'd ask you to do is go look at some recent news about mold in the ISS, mold in the space station. Now, if you believe some nuclear folks that misspeak about this, none of that mold should be growing because this stuff kills everything, and these guys are swinging around in orbit. But relatively speaking, because of the orbit, and it was planned, it is in a fairly low radiation location. The further away we get from Earth, the closer we get into the magnetosphere. That's where those eddies and undulations around the Earth's magnetic field make little waves and clouds that we can't see of specific nuclear materials that get separated out through separations we copy to make nuclear on good old planet Earth. They're electromagnetic separations done in the Earth's geomagnetic regions. It's an atmosphere we can't see, but with satellites now we can visualize it and know about those huge clouds of nuclear heavy particles sitting out in space, or they might be light particles. So that space station is being bombarded worse than anybody on planet Earth is, unless you're near a nuclear reactor, and those energies are specifically different. Remember, this ties into frequencies, which creates a woo story. So I'm going to try to avoid that. But our energy measurements are done in frequency. They're done in electron volts. They're done a number of different ways depending on the type of particle measurements, and then you can turn those into other measurements using math. So, mold, nuclear mold, what is that? Basically, molds and a lot of those levels of things, prions one, they don't care about nuclear very much until they get hit. But so mold, organic elements with very basic, very, very old genetic lines have lived through radiation storms that we have yet to experience because of the billions of years of evolution that those molds did. Those molds are the foundations of some of the oils that we harvest. Those molds and mildews and the red tides are part of Earth systems that were here before us. But they have changed. This is delta. This is measurement changes. So specifically, the question was, what was my opinion on previous starfish die-offs? We've tied them to red tides and algae blooms. Well, those algae have been out in the oceans for a long time. They are very genetically dependent, genetically stable lines that go through massive amounts of churn. So the die-off rate is huge, but the regeneration rate is huge. So chemically, huge amounts of things are going on. The rate of change, in the old days, people used to call this, what did they call this? Decay. It was detritus. It was there's another word for it that's half woo because the salesman used to use it to sell whatever they wanted to, but it'll come to me. So the space station has a problem with molds growing that a lot of folks thought radiation would kill off, and radiation doesn't do that very well. Dosage, right? So those black molds, those green molds, those gray molds that are as old as the dirt around us, comparatively speaking, have come a long ways and evolved and exist. So we already know that. But this change, the ability for them to become something else in those environments, pretty big. That extends out to all organic organisms. So continued exposure to low levels of nuclear waste creates an abnormal genetic churn in generations of species. In the cases of black mold, I'm not sure what its life cycle is, if it's days, weeks, or months, but it grows. It doesn't die. It grows and begins to thrive inside a nuclear reactor. Fukushima, it's already been noted. Black mold. Every reactor has this story going on. There are other stories. There's science linked to these stories, but there's not enough science. Lyme disease is one that has been traced to a nuclear plant location. Continuous exposure to higher levels of ionizing energy can affect genetics. It does affect genetics, period, end. This is how the nuclear industry uses these conversations to blur and distort things. The lines are rather fuzzy. The chances of you getting cancer are rather fuzzy. 1 in 10 now? Is that the numbers? We accept that? We accept it's going to go to 1 in 9? So I talked to nuclear pollution, but chemical pollution is the same way. Long-lived dioxins in the soils, in dirt roads still across this nation being stirred up, and our kids are interacting with it very slowly over generations, because those dioxins, this isn't nuclear contamination, although it could be. It could well be nuclear polluted dioxins and oils that were sprayed. We don't know. We flat don't know. So I don't do these to cause consternation. I do these because we need to understand what the functions of large organizations are within society. These towers of knowledge, these institutions. I think that's one of the most important words here, is trusted institutions. Bring back the definitions of words and make them work. It's part of the challenge out here. Who are you talking to, and who's going to take that word in a strange direction? So, black mold. I use that because you can go search for black molds in nuclear reactors and find numerous instances of this. This goes back to research out of the Hanford Reservation. Again, the bulk of it came out of Battelle Institute studies and their commissioning work to multiple universities and other research labs. You've heard the name Battelle. They're still around. Go look them up. This is a huge institution, a private institution that has the bulk of the wealth about our nuclear sciences. They are one of the majors, and they never come out and play. You won't have one of their scientists knocking on this door, even though we could have a conversation. It's simply not done. And you can see why. I breach a different spectrum of philosophy than a lot of other folks do. So what does this black mold have to do with starfish wasting disease? Well, the starfish wasting here showed up about a year and a half after the Fukushima event. So for a year and a half, the Pacific Ocean had a chance to stew. Now, I brought up cosmic clouds that are up above our atmosphere outside of Earth's hard atmosphere and out into space, between the Earth and the moon space, right? So we are still inside the magnetosphere of the planet Earth. It is a huge, if you look at it over time, it's a liquid flow. You can see the flowing embers through space in some of the visualizations, the CGI that simulates what we can't see. So powerful tools out there doing these things, but we can see those clouds. We know how they form. We know the electromagnetic and the vectors and everything else involved, from gravity and rotation, angular rotation, right? So yeah, there's a lot of folks out there that have a lot of ideas about how this all works. What does this have to do with those starfish? So the oceans form those same clouds under the sea. There's layers and there's actions that go on that have to do with the masses and the bondings and the bindings and how big the molecules floating around in the water are. Then there's the biological uptake components, where those elements are bonded, bound, or they're still floating free and are absorbed into the body, and the body accumulates them somewhere, and you begin that biological uptake chain. So that chain, at the lowest part, are those microorganisms, are those things that put our bodies together, all those little cellular structures. So nuclear eats at those. Nuclear energy, high energy particles, changes the dynamics of the molecular interactions. We know that potassium gives us extra energy through our body. The way it's dispersed through our body, it is a radioactive element, and that little bit of extra energy gives the human body a little bit of extra energy over time. Eat a banana, besides all of the proteins and minerals and calcium and everything else in the banana is that decay product. But guess what? We have been living with that decay product for all of our lives and for generations. Is it part of our genetics? Maybe. Maybe. Genetics isn't just the human genome. What builds the genome is a part of genetics. The RNAs, the oh, there's, I'm not a biologist, but the list of things that build DNA can be interacted with and do false insertions into DNA. So it's not just the DNA itself, it's the machine that builds the DNA that can be affected by this. So yeah, it's big, it's complicated. So given the churn that we know this radiation causes in DNA with the proper historical records, so yes, this is change analysis and figuring out what caused the change. We can go back and look at the DNA and the RNA and the larger structures, because the science has gotten so much better now, and actually identify genetic damage done by radiation to human DNA. How or where that test can be extended to, I'm not sure. What labs can do that test? It was a list of 2 labs. There's probably 5 or 7 labs that can do this, and they're benchmarking each other. Each lab is doing specific research into specific elements or compounds or whatever they're researching, and they're building libraries that are used for the instrumentation in the next generation, because global information systems and geospatial data. So this turned into a 20-minute. I have just bounced off of 18 different components of genetic churn, genetic change, and that old word that keeps coming out about decay, but that's not the word. So could the radiation from Fukushima have generated the next generation of the starfish wasting disease? How would you investigate that? You would have to have samples from across the ocean. You would have to have samples across time. You would have to have some way of verifying that the nuclear actions, the nuclear particle physics reactions, could cause what you're talking to. Now you get into energies and frequencies and subatomic interactions we are just beginning to map out against compounds and elements. So just as we are still creating an optical emission standards reference that all sciences use for optical emission studies, this is the next step, the next generation. Just as we've got this Parker Solar Probe going around the sun, measuring things that no one bothers to explain to us. Another video. So, thank you for listening. If you got this far, this is an intro to just one of the many areas of study in the nuclear sciences. This would be an intro to maybe get you enthusiastic about calculus or algebra, because that's where it starts. Those are foundational principles of the sciences. They're not in one book. If it is one book, it's got a lot of references to other books, or it's the wrong book. So, peace out. Good Tuesday. My coffee got cold. And we can go there. I've been there. I'd rather be by your side. If you want to go, we'll go together.